Hello everyone, welcome to apcalculus. In this video, we are going to discuss the p-series test for the convergence and divergence of the series, and we'll be discussing the proof of that thing. So here, let's say the p-series looks like this. N goes from 1 to infinity sigma 1 upon n power p. This is the standard format for the p-series. So here we will say this particular general term, we will take it as a function. Let fx is equal to 1 upon x power p, and for x greater than or equal to 1, it is positive, continuous and decreasing. So we will apply the integral test. So we'll say integration of 1 upon x power p dx from 1 to infinity. So this is the improper integral we have to solve. Now in order to solve this, we will say 1 to b and limit b goes towards infinity. This is 1 upon x power p dx. Now what we will do, integration of 1 upon x power p will be what? X to the power minus p plus 1 upon minus p plus 1, and the limit is going from 1 to b, where limit b goes towards infinity. Now we put the upper limit in the function. So when we put the upper limit into the function, it is b to the power of minus p plus 1 upon minus p plus 1 minus, if you put the 1 over here, so 1 to the power of minus p plus 1 over minus p plus 1. Now 1 raised to the power of anything will be 1, and minus p plus 1 we can take out. So 1 over minus p plus 1 we have taken out, and limit b goes towards infinity, and we are left only with b raised to the power of minus p plus 1 minus 1. B raised to the power minus p plus 1 minus 1. Now here b goes towards infinity, so either the answer will be infinity or 0 depending upon what is this exponent. So we'll take case 1. If minus p plus 1 is positive, so if it is positive, right now if it is positive over here, so we can say minus p is greater than minus 1 or p is less than 1. So if this is positive, right, so it means b raised to the power of positive number. If b raised to the power positive number and we are saying limit b goes towards infinity, so b raised to the power positive and b is going toward infinity, so this will approach toward infinity. So if this will approach toward infinity, so entire thing will approach toward infinity, therefore it diverges. Case number 2. Minus p plus 1 is less than 0. So here we can say p is greater than 1. So now you can see if minus p plus 1 is negative, so it is b raised to the power of a negative number, negative quantity. If b raised to the power negative quantity is there, it means it will become 1 upon b power positive quantity, and limit b goes toward infinity. Now this time when the b goes toward infinity, so denominator will be very large, which will approach towards 0. So if this part will approach towards 0, so we are going to left with 1 upon minus p plus 1 and 0 minus of 1, which is going to be 1 upon minus and minus will get cancelled out. So it will be 1 upon p minus 1. So you can see this time we are getting a finite answer. So we can say it converges. Now what will happen if the this expression is equal to 0? If this expression is equal to 0 over here, so let us say, or let's take the third case over here. So right now we are saying, now if the series we have 1 upon n power p, if p is equal to 1, what will happen if p is equal to 1? So if p is equal to 1, we will be having 1 upon 1 power 1 plus 1 upon 2 power 1 plus 1 upon 3 power 1 plus 1 upon 4 power 1 plus 1 upon 5 power 1 and so on. This will add up to infinity. So this is diverges. So therefore we are having, if we are having like this 1 upon x power of p, or we can say n power of p over here, n goes from 1 to infinity. So we have two cases. It converges and diverges. Converges in the case when the p is greater than 1, and diverges in the case when p is equal to 1 and when the p is less than 1. So p less than or equal to 1, it diverges. This is the proof for this one. Do check out the next video in which we will be discussing the questions related to this. So if you are looking for one-to-one live personalized classes for AP Calculus, please contact on this given email ID or on this particular WhatsApp number. Thank you for watching.